Million to power million. Good morning, namaskar. This is Engineer Suraj Singh speaking from Bharat, India. On this day, April 6, 2022, Wednesday, 3:15 a.m. मैं सूरज सिंह सिविल इंजीनियर भारत इंडिया से बोल रहा हूँ। आज अप्रैल 6, 2022 बुधवार 3:15 सुबह के टॉक topic is same as usual. You can see title. It starts from real quality at one end and ends at what we are, what we do, and in between we have many subtopics, and that is coordination, engineering projects, works, all designs, reliable engineers, power of communication, concrete specifications, civil engineering, contracts, safety, health and environment, methods, disputed claims, parties on contract. These are various issues, and before coming on to that, let's also see how does it work. This is my email ID. As usual, I show to you in beginning, Suraj underscore engineer at yahoo.co.uk, and this is my international professional engineer certification, as well as this is chartered engineer certification here, and here it is fellow membership certification. This is my quality file, this is my coordination file, and here is concrete specifications of a foreign country for me, and that is Japan. It's materials and construction, it is for that. And now if I take this opportunity to show you again this file, and Chartered Engineer India, which is corporate membership linked. This is fellow membership of this institution, and the quality, real quality and real coordination, which is responsibility for everyone in profession. We cannot just say what we say is right. Real quality is required quality. We should achieve this, and if we don't achieve that, we miss everything. Being an engineer, if one cannot give quality, one cannot achieve it, then I think that engineer cannot be called engineer or real engineer. It's not certainly qualification alone that makes one engineer. It is capability of a person to do job rightly. Why to deceive oneself? There is no meaning in deceiving, because work is work. Why should we run away from quality? That is a question. And why should we run away from coordination when it is very easy? For my understanding, for my consideration, coordination is very easy act. It doesn't require any higher level of sciences or engineering. And not only in engineering but also everywhere it is relative. We may accept it or we may not accept it. We may recognize it or we may not recognize it. But without coordination, world will not move. And that's a fact of life. Coordination is sometimes not understood, that is different. But coordination works. Not necessary that there should be two persons. It works when you work alone. So many activities are conducted every day by everybody, and particularly in engineering world, in construction world, in design worlds. Coordination automatically works. Even if you do not like, if you do not mention it, but it works. When you do design work, we consider many documents. It's not simply because what I say tests. We consider so many issues, and then in design is not a single activity process. It takes time. It considers reports. It considers histories of past. History means what this soil, for example, soil history or area history, or you can say earthquake history or rain history or winds history. If you really do design, you have to collect this information. You cannot ideally take, okay, this is ideal design I do. No, ideal doesn't mean anything. So it's design where coordination is done. It is work there coordination is done, and even in contemplation coordination is done. And brain is best coordinator in world. There can be no better coordination done by anything else than brain. Now it's up to us how to what extent we can use our brain. Brain can be used to maximum extent. No one has used that so far because brain is so powerful instrument, so powerful tool. Everybody has got this. And I don't know why people don't realize this fact that you have got some control on your body itself, which is remote control for your body as well as for your work. And it's very easy to get quality and coordination. It's a very only easiest work I can say without having. Of course, we have basic education and we have basic quality, basic coordination, but we should do that, and I can't run away from that. Coordination is done automatically, but I'm just giving you the right thing, the coordination necessary, because we should keep in mind it's just like system. Quality system, that we produce a system, system existed before it's being formalized. It exists there, quality works used to be done, quality controls were done, systems were done without being mentioned. It's like that we formalize something like ISO 9001 or Sigma or whatever else. Systems were there virtually, effects were there. I think these are far better than this work now. The only thing is formality has been declared. We said, okay, this is system and we have to follow this. And that's fine, that's not an issue. But how far? We should understand this point. And in engineering world, activities are many activities. We can't define activities, but this is one. Every activity has many activities, sub activities you can say. Just like when we plan, we can schedule, we write a long list of activities. We say this is what we have to do, and it depends on types of work, what work we have, what items we have, how we have to move on that, and we list out that. And that's true, we list out, this is my list of activities, and based on which we give time schedule. Generally we call it time schedule, or we call it plan or schedule. Well, that's fine, we consider time, but within that time itself, quality is included, coordination included, because all activities are related to each other, even though they work in parallel or they work in sequence or series. It doesn't matter, but one is related to other one because one has to follow other one. We cannot simply say, okay, start at random. We can't start at random. We must have concept, we must have clearance. We have different type of plans or schedules. We say this is a master plan or level 1 plan. This is level 2, level 3 likewise. So we have further defined that. And that's what means it's really sometimes interesting to note that we have to do something as such. Now question is, what to think about coordination? Why I am separately calling coordination? I am calling coordination because it's required. And we call it reliable coordination, means we have to depend upon. I cannot say I'm not coordinating, I don't want to coordinate, and work should go on itself. Okay, if I don't coordinate, somebody else will coordinate. Maybe some experienced workers, experienced technicians, when they work, for example, they will like to know, those workers will like to know, give me this information, give me that information. Say same discipline coordination. Suppose I don't give details to my workers, my carpenter, my steel fixer, they will come again and again to me. At least 4 minutes will come again and again, or charge and will come again, give me this detail, give me that detail. Or if they don't come, they will consider themselves per practice. And that means me, I'm unable to give details. Then either they assume themselves or they copy somewhere else. Reliable coordination engineering is very important for projects, and we should study projects completely. Study itself is coordination. If we have to study on projects, we have to study all drawings. Let us say in building world, we can say we have to study architectural drawing, structural drawings, electrical mechanical services drawings, plumbing drawings, on whatever else, landscape drawings, existing services drawings, or whatever is possible, soil mechanics, soil report, that's most important. We have to study all these, and these are minimum, and it doesn't take just 1 hour or 2 hours. It takes a lot of time. And even for experienced persons, we have to study given designs, given reasons. We have to study what materials are required, how these materials can be procured, or what is function of this building. Is it right design, or can we review it? And likewise, what are required specifications, include the specifications. Can we manage or can we organize this, or we cannot do that? Or is it going to cause some problem? And that's what, it is actually quality related coordination. We have certain standards that we have to achieve, we should achieve, we must achieve. And for achieving that, there are so many routes. And we have to find routes ourselves, methods of the year, technical methods, working method, design methods, calculation methods, software involvement, quantity involvement, quality involvement, safety involvement. There's no one, no two. A long list can be prepared, but experienced person knows what is required. And that's why experience is important for purpose of communication and coordination. Coordination is a group of communication. Various communications are involved, and we can say it's important for reliable quality engineering. Reliable quality engineering works deliveries. Reliable coordination engineering is a must. A professional engineering note now is just a note for this. Good engineering, and that's very important point. Missing good engineering, coordination, and I would simply say that communication is very important domain. Though I have not written it here because it's included with coordination itself. No coordination can be done by communication, and communication is very general and specific. Communication is such a word where you need importance, you need knowledge, you need what to communicate, how to communicate. If it is required, you have to send pointed communication. You have to send communication where clarification is required. You have to send communication where only confirmation is required, or you have to send some proposal that should be accepted, or if it's not accepted, then the designer has to tell us what should be done. There's a relation between designer and person who works physically. There's a design and site working relations, there's a design and manufacturing relations, and that relation should come into play. It's really very important part. It should come into play and should work, and if it doesn't work, there can be question marks. Domain, real quality, and real coordination are very important. Cannot be, we cannot escape them. Domain of real quality and real coordination are very important. And we say we all are friends together for all others. Yes, we are. But what should do? Where is destiny? Destiny is quality. Destiny is, we have to produce quality work. And that's what we call demanded quality. And I say demanded quality means this is my object. If I don't achieve this, I did not do my job. If I don't achieve it, or I am unable to achieve it, I have to find reason for that. I have to know reason, and if I know reason, if there is reason on reason, then I have to check why does it exist, why it's happening, why it's coming in my way. And if I analyze, I conduct analysis, and I find answer, then I have to apply that solution. And from the answer, it becomes a solution. And that's why quality is very important. I'm not going to teach you what is quality. You know quality yourself very well. Everybody knows quality. But how to achieve it, how to concentrate on that, that's important. My direction is you have to concentrate on that. How to concentrate on that, how to do work with that, that's the important point. Everybody knows work. I don't see them, people don't know work. But a standard, a practice, you both remain successfully without any problems. But why it's not done? Engineers can handle both domains successfully without any problem, but even then it is not done. And that's the point of concern. We require to establish both domains permanently in engineering profession and also other walks of life. There's no issue on that. Again, I say real quality engineering, reliable coordination engineering are very important. Without reliable quality, real quality engineering, real quality means not paper quality or not methods, actually what we do, how we transfer it, how we transmit information that is available within methods, or we design method how to transmit that information to site work, and how to, if we have that information for purpose of design, for design objective, how to include that, how to transmit that to design. In design, sometimes you can say it's not actually based on calculations but also on intuition. It's based on mechanical understanding, engineering understanding, practical understanding of something. Sometimes we assume something and try to justify that, which generally happens in designs, and particularly in construction works or designs or structural designs. We assume in beginning something and that we justify. This means mind is trained by solving problems, and mind is trained by analyzing problems, analyzing situations, and that's what we say working designs, manufacturing, construction procedures continuously. Countries same, people are important, countries lands, countries have got resources and human resources. We are also human resources like workers. Engineers also human resources, with help of whom, because they are well trained people for purpose of progress, for purpose of quality production, and they should not run away from that, with whatever be reason. Quality is our job, quantity we should say, whatever may happen, come with me. There can be no excuse for seeking any concession. Why should I seek concessions? When can we do something? If I am able to do that, why I should run away? I should take responsibility. It's not question of money making. It's question of your soul work. Means you are an engineer. It's your duty to do this, and no pressure from whosoever. Quality is a requirement, and work's quality cannot be compromised. Why should I compromise? And therefore, we do not intend to compromise just in name of fragile existing quality system. There can be nothing as such. We should not be slave to quality system, because we do it ourselves. We manage ourselves, we lead ourselves, we design our systems, and we have to comply with them. Question is, where does real demanded specified quality exist? And there is a simple answer why I will say I cannot find anywhere. Of course, I could not find anywhere in existence physically, but I could not find it. I've been unsuccessful to find it somewhere, anywhere, unfortunately. But where this required coordination exists, it's unknown in its conduct, but it exists in my mind. It exists in my consideration. You have to deliberate for that. Why don't you deliberate yourself? Why it doesn't matter you should deliberate other people. No necessary that you should deliberate in some seminar or webinar. You can deliberate in your own seminar. Your mind status, we have to be very serious about it. Existing red lines to be resolved, and because of requirements of, because of non, you can say, not complying to achieve quality, we can say this is a kind of red line or red light. You cannot cross until light is given green signal. That's why I say, can we bring working environment to quality and coordination requirements? If yes, how to do that? That's the question. Certain red lines there used to be good control in the past, but now it doesn't happen because of many reasons, because of non-seriousness in existence, non-seriousness of people. Some people are serious, some are not serious. I am finding degree of seriousness is very important in works. Seriousness means you have to be in sequence. I mean, it doesn't matter your face to be serious. Seriousness in work, seriousness is thought and taking responsibility. It's not that I'm taking it too easy. If it happens, fine. If it doesn't happen, okay. No, that should not be approach, because engineering is only field where facts are required. Facts are required and physically required and mentally required and design wise required and material wise required. Everything is dependent on facts. Engineering is that branch of world. Other professions are relative one. Okay, medical is different. I'm not talking medical. Medical is also a real world. But when you talk of other organizations like management or like commerce or like something else, where something is already available, you have to just relate it, to sell it, to purchase it. But in engineering field, you have to do it. It may be manufacturing world, it may be industrial processing world, it may be construction world, or whatever which we call development, which we relate to GDP or whatever. Means that I'm talking, there is no branch of engineering or in engineering which does not relate to facts. Facts or truth, you can say. You cannot use fake statements, you cannot use falsehood in engineering, because engineering is material oriented, it is material related, it is human resources related, it is technical related, technology related. And when it is related to all these means we cannot say, okay, I say, okay, fine, we don't do this. Means you cannot just run away from that fact. And that is what the engineering is about. So we can say, we can simply say, can we know, means can we know and apply product and work quality standards complied with overseas. Overseas, I'm just saying because I have experience overseas and find there's a difference. In those days it was a difference, today also there may be difference. Can we work on required coordination, bearing activities, and that's point of importance. Can we do that? And that point, we cannot just skip. We have to understand that point. Can we do it? And if you can do it, why don't we do it? That point is very important. Missing real coordination means missing good engineering. Can we miss good engineering? I'm not talking of excellent engineering, I'm talking of good engineering. Can we miss that? We have to raise question to ourselves. Can we miss? You act on that. And that action is real action, that action is not imaginary. We cannot simply put disclaimer on job, this is all. We don't take any risk on this, we don't take any risk assessment. Now what for why we should be design if we don't understand risk? This means it is complete work, and design and construction are complete works, because Our works are based on design. It's not just we stand on site and do whatever we want. We have relevance to design. And that's where we say coordination among design, coordination between design and site work, coordination between this discipline and that discipline and all disciplines, and coordination between this technical work and this contract, coordination between many other such sub disciplines are required. And that's the point where we have to be very serious about coordination. Engineering community have to answer that with respect to involvement in entirety. Can we ignore these domains? How can we ignore these domains? How is possible? What do we engineers think of our issues? As mentioned, many of us do conduct works for quality and coordination engineering. Is it not right time to contemplate and deliberate on this subject? Can good industrial practice be achieved without moving through quality and coordination domains? Can engineering designs be reliably carried out without involving quality and coordination? But where are we going to? And that's what we say. We have these very, very minor questions, but these impact on projects, impact on communication support is very much. And communication should be clear, it should be precise. We don't have essays. If suppose I say I have the right method statement, it doesn't mean I have to write books, I have to write facts, a sequence I have to write. And that sequence should be so beautiful, it should be so simple, it should be so comprehensive that other person who reads this should not file something over this library to read, means how many pages I have to read. I am sitting here to read all this, I have to work. Means it should be kind of normal instruction. Means I'm not going to give you verbal instruction first, I have to give you this paper. You read this, and if you have some doubt, you can ask me question, because I am giving a very simple script and you can understand very well. I know you don't have a very high degree of educational qualification, but your importance lies with technological work. Doesn't matter how much non-academic or non-technical qualification you have. You must have technical qualification because you are going to take risks. We are testing upon you. We rely upon you. For you have to include our materials. You have to use them. You have to produce something permanently. There's so many projects that many times we have discussed, and we will keep discussing them. It depends on, there's so much. For example, this is some plant circuit, you can say. It is a processing plant, you can say. This is you can the kind of process, how we handle this, you can say. So many areas are here, so many foundations are here. For example, we can say here naphtha comes here, here it comes here. These are all gases, and there's a cracking area here, cracking furnace. If you crack them, and then we can see this goes further down onto one side, get a prime. There's a steam here and quenching here, and both are done, and then it goes to primary fractionator, and we can see it goes in taking many compressors and many converters, all that. It's like that. Means so much coordination. You can yourself think if so many links are there, so many trains are there, what level of coordination is required. It's not civil engineering coordination, it's engineering coordination. Various branches are involved: mechanical, electrical, civil, or you can say all others are required here. Chemical processing, which is very important for plants. Likewise, you can imagine, okay, it can be done. It's very long process. It's very long process. Means it's very. You can see this is a process plant here. It's looking very small, but it's in kilometers. You can say kilometers by kilometers, and these are all very big units here. All processing plants here, and you can say so much work is done that will take years to complete this. Even hundreds and thousands of people work there, and that's what we have to be very serious about, because it tells us how much cost is going to be invested on that, how much time it will take, what resources we have to employ, and this is where it's very important to be pinpointed, and that's why I say quality is a question mark here. Can we work on required coordination bearing activities? Can we work on required coordination bearing activities to achieve defined or expected quality profile on works? Why should we why we should not revisit quality required specifications and update per world working standard requirements? Why should we not apply work relational coordination requirement? Is it not a most reliable solution? Really, we have certainly worsening state of quality of works and how to improve such mandated works. When I say mandated works means this must be done. Is a question, big question. Must be done quality to a certain minimum required marks. Should not force also to work on coordination in each activity and worsening state of quality of concrete and how to improve such mandated quality to certain minimum required marks. All such issues are very important from one point of view or point of view, from this point of that point of view. And point of view can be defined whatever way. Should not force ourselves to work on coordination in each activity and worsening state of quality of concrete and how to improve such mandated quality certain minimum required marks. Concrete component is very important one. Concrete component, that is concrete in terms of plane, it must be in RCC form or pre-stressed concrete form or whatever form. It's very expensive, it consumes materials, it consumes resources like human resources, and it's done forever in a way. When something is going to work for what time we do not know exactly, we can only estimate, we can only assess so many years, and that can be called permanent work. Permanent work is very important on every project because works are designed for permanent work. We have temporary works also, we have preparatory works also, but those are not taken as permanent works are taken because those are supports to permanent work. Temporary work, or you can say preparatory work, or whatever kind of such definitions, all converge into permanent work. And there is no end to permanent work. Permanent works are sequence, means for one project there may be how many permanent works we do not know. It can be listed out according to our chart, our schedule, and we can say we have to depend on concrete is one such material. It is such a material that it's not simply called raw material, it's artificial material, artificial production. You can say it's like rock. Rock, of course, concrete is not rock that way, but it's such a rock equivalent that rock is sometimes lower than what concrete is. So it becomes incumbent on us to care about quality of such component. It's of course out of common and professional understanding. But why do we have no seriousness in this regard? Worsening state of communication and coordination during working for engineering designs and executions or construction activities, and that's where we have to be very serious about. Determined and dedicated role of engineers towards realizing these requirements, or else quality remains a myth. We don't want that quality should remain a myth. It should be a real one. It should be a required one. Are we, can we do it, or we are incompetent, inconsistent societies and communities in engineering? Are we engineering force or incapable not? That's what we have to see. Are we competent engineers? And when shall we open our eyes? And we can say, when shall we awaken ourselves? We have no dearth of engineers, we have no dearth of professionals. But why I'm not finding quality? You ask yourself, why are you not finding? What percent of quality you are working with in your callings, in your works? Shall we transform this engineering strength into standard quality working force? Who shall decide about such questions that are being asked? That deliberation is also important from each and every viewpoint. Information must be brought to those persons who require it, or it must be provided in right time or right requirement and quite rightly duly coordinated. And that is very much first step where we have to think, we have to confine to. And whatever information is required, that is to be provided to person who work in front line, foreman, site engineer, charge hand, or those workers who directly work on this, whoever are there, our people, subcontractor people, concrete people, or whoever organize that activity, information for that activity, respecting that activity, must reach them duly understood. It's not simply I give a piece of paper to them, follow it. No, that is not final work. It's my duty, it becomes my duty to explain to them, instruct them clearly what they have to do, and also make confirm whether or not they understand. They should know what they are going to do. It's not necessary you have to give in writing or take in writing. It explain to them in form of sketches or by convention, by work experience they may understand in their own language what foremen understand, what site people understand, or what those direct workers understand. It's duty to explain to them how we have to do. If once time one doesn't understand, second time you have to explain to them what information is available, and you have to keep a watch on that, which we call surveillance. Means they should know that someone is there to be over them, to make sure that there is no problem caused to work. That's why it says information must be brought to those personnel, those people who require it. Who require means they are our people on job. They have to implement that job, they have to implement that requirement. Who require it, and it must be provided in right time, and that's important. It must be provided in right time for right requirement and quite rightly duly coordinated. Dissemination of engineering information about quality requirement and how to transform using method statements, and that's where we have to deliberate. Means it's not simply if I write this sentence my work is over. When you say dissemination of engineering information, you have to inform them to everyone. Information was even if it's not done on site for sake of information, for sake of knowledge accumulation or strengthening knowledge, whatever we have. Dissemination of engineering is very important in telling information, whatever we have. It may be design information, if there is some particular understanding, particular questioning or particular requirements in design, that must also be explained to those who seek information. Not necessary. You cannot say, oh, this person's site has got nothing to do with that. We we have to try to teach them. Teaching them is our responsibility. If I know something and that's required in job, I have to instruct this is to be done. Why it is to be done, that's also important. Let them understand why it's being forced. So they should not consider the instruction as force, but it's direction, it's guide, teaching. And in job always teaches very well. Remember, job means on site we learn a lot. We learn a lot and cannot learn otherwise elsewhere. That we can learn in field. Field means practical field. We learn a lot, which we can't learn from books. And from books we can only learn whatever is written by authors or whatever was included in examination is included. More than that we cannot learn. That we can, of course, sight learning is not that rapidly as done in classroom, but this learning is a real one. This learning is practical one. When site is available, you work on site and do the right job. Your group does right job. Your engineer checks everything, and you are given complete information. That becomes a practice, and then it becomes a practice means you have to every time what you do work, see that okay I got everything, and that's why I say dissemination of engineering information about quality requirements and how to transform this using method statements. And method statement is very different. though it relates method only, but method is method. Means we should not live, we should provide complete information to those people who have to implement that. And of course, I'm not talking of method statement design because that's very high words. No? I'm interested in quality, and for quality of works means the relation to site, and even as a from manufacturing one it can be, and we have to, our people should know. It's not simply one spare part that I'm talking is happens mechanical parts talking something. There's no mechanical part here. It's natural material that we have to include on works and make them different properties, different attributes after doing that job. Example is, for example, concrete itself is mortar, concrete, or such materials which are produced on site, and these cannot be allowed to stay forever or for many days. We have to use them properly, design them properly, mix them properly, and we have to include them in a way that this is a technical process, you can say. It's complete technical engineering process. Some people call it manufacturing, some call it mix up and do something, some call it whatever you can say, means placeability or filling, or you can say casting or pouring, whatever we can say. And that comes, that should be included in method statement in a way that every step is taught, every step is informed what you have to do at this moment. Sometimes people are so sure that they know, we though I know the study, this is a method statement, I know how it is done, I know everything about this. But method statement is not general one. Every activity has got different method statements. Method means here question is method and not of design. My method is not design. It's just a way how to do something, how to comprehend that. And that's very important point. How to do something, and that's really one. How to do it, what's way. We cannot simply say because I have done it to follow it. Actually, that's not only way. We have to be very serious about this. That method is just like we say, what is your method? It's a methodology. And that method should be comprehensive. That method should be, acceptable. That method should work. That method should not be challenging. That method should be cooperative. It should be based on cooperation. And what cooperation is required, that's also included in the statement in a precise form. Precise form, everybody understands. And that's really very much surprising. We can't do it. Why we can't do it? That one is important one. But be realistic about this. So what realistic? So when you say method statements, this means for that activity you have to be very clear. What actually do we want? How do you want to do this? That's also should be very clear. That's a requirement. And my person, or I say my juniors, who do you deal with that, they should be given clear instruction. Means I am not saying that one should stand with method statement. They should be given, of course, copy to foreman level. Foreman level should be given that. Site person whoever is responsible should be given that every person who has to supervise workers, who have to use materials, concrete, who has to use shutter, who has to use steel or include them on works, they all should know what they have to do. Practice exists, but sequences are important. Every carpenter knows how shuttering is done. Every steel fixer knows how steel is worked, how cutting and bending is done. Every concrete gang person knows how pouring is done. The question is not that they should know what I have to say. Question is what they know should be further improved. Everybody has experience, everybody knows, but something they have to be taught, like straight lining is important, plumb is important, tolerances are important, pressure of concrete is important. Pressure of concrete can open sides and can bulge, or you can say shape can be out. Likewise, concrete temperatures are important, weather temperatures is important, cleaning is important, cooling is important, or you can say even safety is on top. They should understand safety also. They should consider human as human. Generally, sometimes people are angry. They are more concerned about work progress, and sometimes they ignore why you are sitting, you are not working. And of course, at that time, maybe person is so tired, so fatigued that person does not understand what to do. 40 degrees temperature, 45 degrees temperature, in hot weather particularly. So you can say when you write, when you include methods, when you describe methods, safety of workers is also an important point. And generally we use safety in every method statement, just like we include quality element, safety element is included, quality element is included, resources like material elements included, or whatever resources workers we have to use, whatever important tools or machines that are required to be used particularly for that purpose, for that activity, and how we have to do it, how we have to conduct, what circulation should be there on site, because particularly for concrete activities, concrete is not just small activity, it requires everything. It requires transit mixers, it requires batching plant, it requires circulation roads, it requires access on site, circulation on site, enough space is required, and quantities, it depends on quantity, what quantity we have to do, which area it is, or what we can say according to space, what block it is of concrete we have to do. It's so much is, it's a kind of very small project in major project. There are so many small projects in every major project. If suppose a project has to be produced in 2 years, and after those 2 years, 24 months, there will be 12 months or 18 months for completing itself. So you can say domination of work is concrete. Other matters, maybe machines may be procured ready-made. All those may be procured ready-made from whatever source. Air conditioning machines may be procured duly manufactured from overseas or off or remote areas, but these are to be planted on concrete plains. Same way, sectional water tanks, these can be procured, but these are to be planted on plains. Or this may be other water tanks, or they may be transformers, there will be switch gears, just like we included substations, electrical substations. Means activities are direct. Concrete is very important activity, and that's why we have to be very serious. And it's not simple concrete itself. Which level of concrete it is, which area it is, and there are so many gradings in concrete. Everybody cannot just listen to them. Maybe for workers it's just availability of concrete mix, maybe ready mix or mixing on site. Generally, ready mix is life now, not site, until there is a requirement or emergency. So you can say ready mix is very important item, and It's big work for every workers because it cannot be controlled directly. There's complete control. And as I said, safety requirements, safety element, safety element, you can say quality element, material element, or workers element, or machine element, or you can say testing element, whatever, everything. And not only pouring concrete, but also before pouring, we have to do preparatory works like steel fixing, and before steel fixing, you can say your form work, and before form work, you can say supporting system, and before supporting system, available ground or available floor, whatever is the means. You cannot simply say, of course, workers understand how to do, but they have to be trained particularly for accuracy, for time, because time is important and quality is important, cost is important, other factors are important. And this is a combination of all that coordination works in, and method statement is also a part of, partly you can say quality, partly you can say safety, partly you can say resources, partly you can say technology, and a combined efforts, combined application of these can be said method statement or coordination statement, I should say rather. It is based on coordination. It is based on coordination. That's very important. This fact cannot be denied. And if we deny this fact, we deny ourselves. We denied ourselves. Why we deny? And that is really wonderful to understand. And that's what I say, dissemination of engineering information about quality requirements and how to transform using method statements, how to concentrate on construction method, decision making, how to concentrate on construction methods, decision making, and that's an important point. Resolution to do right work for specified requirement, and all these requirements which we have, which we know, maybe writer knows, maybe site responsible person knows, they talk together, they talk with quality person also, safety person as well, and they all reach, okay, that way we can control it. And that process, particular process for every activity, considering from time to time, invariance of weather temperature, weather conditions, those conditions, those agreements, verbal agreements can be projected into method statement so that everybody understands. It's not a document that is legal one, it's a document that is cooperative one. Cooperation, you can say cooperation among various people, various personal, various sections, and coordination as well as consent or approval by everybody. Alright, we have these limits. And you will do this, and that limit which is defined is called processing or quality limit. That we state all together that we should do like this, and that's why it's called method statement. How we are going to do this? We are going to do this way. So how to transform using method statement, how to concentrate on construction methods, decision making, and that's what we say. This is a kind of concentration, and this is, you can say, we decide, we agree with how to follow, how to do this activity, and that's really wonderful. Every engineer has maybe, I can say hardly 2 or 3% engineers only. Sorry. Hardly 2 or 3% engineers maybe. able to write such statements because it's top level job. I don't think everybody can write it because experience is required. Experience is leader. Experience is leader of writing and producing a statement, and it's a kind of, you can say, internal agreement among various parties, among various parties, in a sense that we have ready mix, we have contractors, we have engineers, we have disciplines, and all are cooperative parties. There is no competition but cooperation to achieve quality, and that quality is wonderful if we can achieve. That's what I say, how to concentrate on construction methods decision making. And this is big decision making. I have been behind method statements, but I think I did not draw any happiness towards professionalism. I think designers and others, they're not aware of this, unfortunately. It's not only in our country. I have experienced same overseas as well. So I say that overseas, particularly in Gulf countries, yes, there is statement, there is quality, but I would say our community of engineers, and in particularly civil engineering community, design engineering communities, they are very top profile people, but as far as methods are concerned, comprehension is very low profile. I'm speaking with responsibility that I have not seen enthusiastic engineers about this method statements, because this is root of solution. If you want to get solution, only way is plan. A method statement is like a plan. Method statement is like a plan, and which is not, which is flexible. It's a plan to decide. It's a plan to think how to use resources optimally, how to use time optimally, how to spend money in a right way, and how to achieve quality to maximum requirement. Method statement is not something you should be fearing. It's just a kind of contemplation. This is best way I think. Everybody should say this is best way I think. And other man say yes, your thinking is quite logical. It is no conflict. There should be no conflict. Everybody has different experience, exposure. Safety person insists that people should be safe. They should not be subject to adversities. Same way material should be used properly. And we know time should be given. And there should be no undue pain to anyone. And work should be done according to mandated quality requirement. And we should not fight. We should cooperate rather. And that's why I say input from quality, safety, material, vendors, all inputs are taken, and inputs from engineer, input from whosoever are taken, and we have to understand natural conditions, weather conditions, and material relations. And that's what I say. It's not small work from quantity point of view, from quality point of view. Reason being that whatever work we do here in concreting particularly, which we are responsible because we are producing it. We produce ourselves. It may be through vendor, whatever, but we are responsible for its future strength. We are responsible for its conduct, for its durability for coming times, coming decades, maybe 50 years, 100 years, 150 years. None of us would be available, but work would be available, concrete would be available. So we have to keep in mind that we are doing very high profile job. It's not electronic item, it's not small radio, it's not television that we can know within few years how does it work. We can know a mobile may be useless after 2 years. And we know likewise some other item may be useless. My car may be useless after 2, 3 years or 5 years. So we spend a lot of money on car, but we won't think of material that's going to be used for coming maybe for centuries, who knows? And that's what I'm saying, that method statement is a kind of super design, you can say. It's not simply design, because design is based on codes. Design is based on formula. But method statement is formula-less. It is designless. It is technical. It is experienced. Practice that you have experience. That's why I say method is very important term. You can call it method, you can call it procedure, you can call it sequences, you can call it cooperation, you can call whatever. It should be fit enough, it should be comprehensive, that it can be implemented. It should not be exhaustive, it should not be undue, it should be based on practicality. And also nobody should be rigid in this, because it's a way to do best or better than best, you can say, better than best job. That's why it's very important. I'm trying to take time on this because people have to understand methods. I have written, I have advised, I have proposed something to engineers on some website like Safi, like LinkedIn, which are very dominating in your site. But I have felt that people are not interested, engineers are not interested. Forget people, forget common citizens. Even engineers are not interested. I don't know reason behind that. Design is very important work. I think exclusively top work. But design has to be implemented. Design requires to be implemented. But how? Why that engineer who works in design at least provides input on design drawings itself? How it to be done? How is to be done? Nobody does it. That's why I did not get any response. I did not get any questions, any queries about this, which is very important. It's a part of quality. Method statement is a part of quality. It's a part of construction. It's a part of comprehensive thinking. Means we want to do this way. Is it right? And if everybody says who are going to be involved, who are involved on us, yes, it's okay, it's right, we agree with that. Oh, what's wrong with that? I don't know. I don't know the reason behind that. Why don't you understand that point? Why don't you consider that? Well, I say that with my contemplation, that for me it is something interesting, and because people are not interested, that's different. If engineers are not very much inclined to do this, how can we expect that those people, those personnel, those resources involved on site, like foremen, or you may say site engineer, foreman, both, charge hand, and our workers, concrete people, preparatory works people, temporary work people, how you expect them to value this? It is engineering job. It is very much engineering job, because it is processing. You can say it's a complete process of working that we define, and it is based on every activity. There are many activities involved in every work. Those activities must be very clear. Of course, we cannot buy a book and say this is what we have to do. This is a part of book we write, cite. Maybe some site has got hundreds of such methods. Some site has got only 10, and some got few. That we have to be clear about. That method statement is a command. It's a command like DOS, Windows and DOS. I can say method is a kind of software though it's not that type of software, but to soften your hardness of problem, I can say. To soften hardness of problem, it gives a clear concept. It brings in if something misses, and it brings in every partner, every stakeholder on site to come to one point, and that's what we say kind of is the instrument to coordination engineering. It's the instrument to communication engineering. It's an instrument to gathering together and deliberate. That's what it is. It's a powerful document. We call it professional document also. Because it's not only document because it's not record only. It's not for purpose of record. It's purpose for work. It's meant to change. It's meant to produce. And once it is produced, it is success. If we comply with that method, it becomes a success. That success is construction. That success is something else also. We can use it wherever we want. People call event management. What is event management? It is nothing but method of that activity, or you can say that event, whatever it is. Method is event or activity, we can say. Event, we call it in CPM. Activity also we call in bar chart. This activity, that activity. Every activity has some, maybe it is small, it's big, but some procedures for that activity exists. And there is no definite term as such. You have to define yourself. And that's why I say engineering, construction engineering, civil engineering is different. That even designs are different. Because designs too, you can design same product, you can design proposal in many ways. Likewise, we can design how to construct it. So construction design is that your way, your procedure, your process, how to move. And that's why method statement is not easy term. We should give full value to this if you understand that. How to transform using method statement, how to work using method statement. It's a point of concern, it's a point of understanding, it's a very important point. And if you don't understand this, nobody can teach us. I try to explain something, I'll try to explain every day because it's very important. I will request engineers to concentrate on this along with design itself, because your guidance as designer shall value a lot to a person who is the kind of who know basics element of designs, but your design has to be implemented by that person. Keep that in mind. If your design is done well, it's transformed well on site, it's your success. You can say with pride, this was my design and it has been done very well, so it shall work. Per my assessment, for so many years, this material shall be safe. What I contemplated would be successful. It can be done only when your design is transformed to physical work. And if you can't do that, then your design is happiness for you only and not for that person. Your design should give happiness to that person also who walks on site, who stands in sun, adverse weather conditions and walk there. Sometimes no facility is available there. As I say, how to concentrate on construction methods, decision making, and that is what means. You should have leadership in that. As a project manager, organizer, or whosoever you are, engineer, you should have that capacity to reach agreement on by all stakeholders for method statements. And it's not concrete. So many other items are there. Concrete we are referring to because this is exclusive item of full control. No, nothing is made elsewhere. Even if you do precasting, pre-stressing, it's done on site or maximum workshop, factory. But all other methods, brickwork, block work, plastering, rendering, flooring, sanitary, water supply, HVAC, or whatever else, you have just responsible for installation of those items, not more than that. Items are well manufactured in some industries, some factories, and procured to site for purpose of installation or purpose of pulling them to commissioning, or purpose of testing and commissioning and operation. And that's why you can say those are engineering wise, site engineering wise limited. But as far as concrete is concerned, it's fully everywhere. Blocks are also available in factory and we get them. Same way bricks and steel, we get them likewise. So I'm saying is resolution to do right work for specified requirements, amount a lot, question a lot. Resolution to do right work for specified requirements. That's where we have to see resolution to do right work per specified requirements, and that resolution is drawn on the method statements. Whatever we agree, we have to do that, because everything cannot be written. Experience counts, and that's why we describe on statements also responsibilities of those persons, the stakeholders, key holders, key personnel. This is their job description. They have to consider these points while working on this activity. And that's what I can say. Resolution to do right work per specified requirements. Methods can be designed and drawn, stated for designs, for execution, for carrying out activities, as well as for rectifications, remedial, and for services. Methods means comprehensive methods and not selective ones. No work shall be done, no work be carried out without referring to method statements. That means if method statements are available, and if these are not available, then you have to make them available, or you have to make typical statements if you have from past, from history, for typical activities which must contain safety, health, environment, and quality approach at every possible and convenient stage. What about contracts for construction? It's very important item, very important in the sense that generally civil engineers skip. And I sometimes smile, I sometimes laugh. Why we skip? Why do we skip? Is it not our job? Yes, it is not engineering, of course, not absolute engineering, but it is implication of engineering. Means if we don't value contract, if you don't value in a sense, I don't want to understand contract, then I would say I'm an engineer. Like there leaves to be some nonsense between this. If I am an engineer, I don't understand contract, or I do not understand contract. Facts cannot be denied. Contract work for engineers and engineers work for contract. You work in designs, that's also contract. You work in construction, that too is contract. Even if you don't employ contractor, you do it as well. Again, you have to deal with your supply contracts, this contract and that contract. So it's important. I think it's very interesting for intellectual person. If you want to use your mind, if you want to use your mind like a lawyer, contract is that field where even lawyers cannot be knowledgeable, judges cannot be knowledgeable. Not knowledgeable in the sense that they don't understand language. It's not question of language. It's question of implication. It's question of objective. What objective it is? Contract document is very powerful, because this is also agreed by responsible people, owner and contractor, and this is supported by expert who is engineer. The engineer is not a party to contract. Engineer is a party with employer on another contract. But when you are talking of contract, this is project contract. Project contract can be construction only, or it can be EPC, engineering, procurement, and construction, or it can be design and build, whatever you can say. That contract is powerful. That knowledge of contract, I don't say that a fresh engineer should know that, It's not possible even fresh engineers qualified that. Suppose we say I have qualified professional read them, you think that's enough? Yes, you can say exposure is there. If you read bare acts for just getting information, what does it mean? What's the purpose of this act? Why it has been there? What conditions here? And just like constitution of this country we have, this is the constitution of the country, constitution of Bharat, India. And what's written there is just a small book of 400 pages or 200 pages, but that is text, that is facts. Implications are different, and that's to say, implication is more important to know, and it is known by experience. It's understood by experience. Just like we can pass engineering examinations, all subjects, and say, got this certificate of degree engineering or masters or doctors, it's okay. But did you understand engineering? That is question number one. Did I understand engineering? I have to raise this question myself. Because when you learn in field, you work in field, you work on your own responsibility. But are you ready for that? Are you ready to accept for wrongs, for rights? That's the point lies in. So as I say, no work can be carried out. No work can be carried out without referring to method statements or procedure statements or quality statements or whatever, which must contain element of safety, health, environment, element of quality, and element of design, element of practice, element of whatever is conventional. All these approaches at every possible and convenient stage. What about contracts for construction? I said this is that. If I don't understand contract, I don't understand anything about that. That's my problem. We have to understand, forget what salary you have. You should not say this is my expertise and that's not my expertise. Contract is not expertise, it's a requirement. It's not your choice, it has to be done. And because you work with a contractor and contractor works with you, and that is because of project and also contracts. Contracts can, change everything. You have to administer contract as an engineer. You have to work on contract as contractor's agent, and we as owner also contract is responsible because owner has full establishment, full liability of that. So we can say contract must be known to engineers, and it's known to everyone. If you think of how contract comes into, what's value of this in law, and I would simply say every country has got certain regulations, certain rules about contracts, and our country has also got that. We Bharat India, we have Indian Contract Act, and that Contract Act means it's not that document you think it is. It's just the points and pointly documents. Various points are given per law, and means these are acceptable under our Contract Act. This is our Contract Act. These are main points. Those main points are important, and this means whatever contract we do in this country, that is covered under Indian Contract Act. If it contravenes any conditions of Indian Contract Act, that condition of that contract becomes void, not all contract. Keep in mind. And we can say, why do we not understand this point of contract? We have to understand contract point, and it's very important one. We'll discuss contract later because it's very long talk. Contract cannot be discussed just in a few minutes. And then we have to understand about design quality contract, or we have to about design contract or construction contract and other contracts, and then we have to see disputes also in that. Now because now it's long talk and I don't want to bore you, so I think we have to be very careful on this issue. Again, I just told you my email ID, which you can say is suraj_engineer@yahoo.co.uk, and this is my certification, this is my quality talk I just say. And of course now I'll go to a file of concrete specification, which is we may say very important one. And we're talking about pumping last time, and buckets. I think we're talking chutes and buckets. Let's start with this. Let's see what we were. Just overlap. We may say vertical pipe equivalent to, I think we have done this. This is integral horizontal pipe 164. I think this we have done, pressure loss and all that. So we will go there. That is concrete limits. Okay, the few points that we discuss for overlap for sandwich. I'm doing this. Says volumetric efficiency of pump. Okay, volumetric efficiency of pump. Volumetric efficiency of pump varies depending on concrete mix proportions, properties of fresh concrete, and actual discharge rate is smaller than theoretical discharge rate. Let's go to see pumping also, pumping of concrete in some such model if I can get. I always have interest in that. Let us see if we can get some more information on pumping of concrete. Pumping concrete. Let us see if we can say something here. Pumping concrete. If I get constructor.org, say same thing I was in concrete. Wikipedia, let us see Wikipedia because it's very important. Wikipedia I'm opening now. This let's see what it says, and how does it say concrete pump? It says a concrete pump, according to Wikipedia. I'm reading it from that source. I may open it. It's very small here, so I don't think it's anything. I'll read for you only. A concrete pump is a machine used for transferring liquid concrete by pumping. There are two types of concrete pumps. First type of concrete pump is attached to a truck or longer units or on semi-trailers. It's known as boom concrete pump because it uses a remote controlled articulating robotic arm called boom. To place concrete accurately, boom pumps are used on most of larger construction. Most of larger construction projects, as they are capable of pumping at very high volumes because of worker saving nature of placing boom. They are a revolutionary alternative to line concrete pumps. Second main type of concrete pump is either mounted on a truck or placed on a trailer, and it is commonly referred to as line pump or trailer mounted concrete pump. If I can just take just a print, let it print, so you can also see, just to show to you I'm printing. Preview, I'm just finding it's coming in, loading preview. If you can get here, I'll show you that it is for reference. Even if you see something is better, that's important. So something has come, let's print it and we'll read it then. And let's say good, if it comes and we discuss this. This concrete pump, of course. Let me put on. Up. Hold on, please. This is coming in. It's work is process. It's processing. Yes. You can see in meanwhile. You can see just minutes, seconds. In seconds, you'll find it. It's come. Yes, it's come. And it's not coming. It looks like it's taking time. Well, I think there's some problem. Why it's not coming? What's the reason? It should come. It's come. Okay, it has come. Yes, it's come now. Because of memory issue, I think there's a problem. Memory issue, I'm sure. It's here, you can see. Oh no, it's not here. Concrete pump is here. Yes, it's here. Okay, it's come. I'll blow. So it's a concrete pump. Now you can see. Concrete pump is a machine used for transferring liquid concrete by pumping. There are two types of concrete pumps. First type of concrete pump is attached to a truck or longer units, as on semi-trailers. It's known as boom concrete pump because it's used as a remote control articulating robotic arm called boom to place concrete accurately. Boom pumps are used on most larger construction projects as they are capable of pumping at very high volumes, and because of worker saving nature of placing boom is a revolutionary alternative to line concrete pumps. As it is because it is fluid. Because it is fluid, concrete can be pumped to where it is needed, where the concrete transport truck is feeding concrete to a concrete pump, which is pumping to where a slab is being poured. And here's what you see. Boom pumps are used on most projects as these are capable of pumping at very high volumes, and because of work saving, this is pumping concrete into aluminum concrete from work in Mexico. Alright, this is one. And you can say second main type of concrete pump is either mounted on a truck, and it is commonly referred to as a line pump or trailer mounted concrete pump. This pump requires steel or flexible concrete placing hoses to be manually attached to outlet of machine. These hoses are linked together and laid to wherever concrete needed. Length of hoses varies typically of this depending on diameter of hose. Line pumps normally pump concrete at lower volumes than boom pumps and used for smaller volume concrete placing applications such as swimming pools, sidewalks, and single family home concrete slabs and some slabs. And you can say they are also skid mounted and rail mounted concrete pumps, but these are uncommon and only used on special job sites. History is that until 20th century, concrete was mixed on job site and transported from cement mixer to form work either in wheelbarrows or bucket lifted by cranes. This required a lot of time. In 1927, German engineer Max Gies. In 1927, German engineer Max Gies and Fritz Hull came up with the idea of pumping concrete through pipes. This pumped concrete to a height of 38 meters and it is 120 meters. They pumped concrete to a height of 38 meters and distance 120 meters. Shortly after, the concrete pump was patented in Holland in 1932. In Holland, in 1930 by Jacob Cornus, when this patent incorporated develops previous German patent on mechanism. What is mechanism? Concrete pump design has faced many challenges because concrete is heavy, viscous, abrasive, contains pieces of hard rock and solidifies if not kept moving. Usually piston pumps are used because they can produce hundreds of atmospheres of pressure. Hundreds of atmospheres of pressure. Such piston style pumps can push cylinders of heterogeneous concrete mix. Aggregate. Now, pump below uses a transfer tube valve and one in right uses seat valves. Examples of pump here is piston pump with seat valves and is pump here actually. This is machine. Other stock is very important. And here this goes to delivery here. Example of pump performance to illustrate below are data on typical concrete sample. As you can say, we say A, B, C, D, A, so B is written. It's now operating display here is BRF. Now, so vertical reach of boom is 41.9 meters. In this case, boom is 41.9. Horizontal reach of boom is 38 meters. Pumping rate is 30 cubic meter per hour. Concrete pressure 112 bar. And cylinder length is 2100 mm. Cylinder length and cylinder diameter is this. Number of substitutions of strokes per minute 57. Strokes per 27 means now you can say per minute. And number of outriggers legs 4 maximum head. Now is a gallery pump. Construction site pumps, you can see these pumps here. This is called construction site with concrete pump, put Mr. Concrete pump, and also here is concrete pump, you can see here. Put Mr. brand positive placement, and you can see how see. I have something else here, some other file, and that's what I like to show you. This was from Wikipedia, little information, and that's important, of course. When we have to see if someone has something else, we can have. And what's coming in, and let's see. Concrete pump. What is pump concrete? And of concrete pumps types. There's nothing specific. I close it. Leave it. Close it. Don't waste time. No meaning wasting time here. I'll say okay. We come back to our file, and that's here. We come back to a file, and that's what I'm saying. So we come back here, and this is volumetric efficiency of pump varies depending on concrete mix proportions, properties of fresh concrete, and actual discharge rate is smaller than theoretical discharge rate. Since rate of placement in construction plan is average rate of placement work including such tasks as moving pipe and compacting concrete, actual discharge rate is higher than the rate of placement. A discharge rate assumed for calculation purposes therefore must be a value reflecting volumetric efficiency of pump and work efficiency, and it is necessary to draw up a plan so that pumping can be performed smoothly even at that discharge rate. Number of concrete pumps is determined in view of rate of pumping, discharge rate for type of pump to be used, size of concreting blocks, volume of concrete to be placed. In order of placement, rate of placement, state of supply of concrete, compaction capacity, number of placing locations for concreting work that requires continuous placement of concrete. It's good practice to prepare backup concrete pumps. If difficulty is expected in pumping of concrete, it's necessary to check functioning of concrete pumps Pumping loads, test pumping under realistic piping conditions. Pressure losses in pipes and changes in quality of concrete due to pumping are largely unknown because these vary depending on type of concrete used. Concrete conditions and environmental conditions. Type of concrete and construction and environmental conditions that require careful consideration in connection with pumping, including following. That's pumping of plain concrete with cement content of less than about 270 kg per cubic meter, or rich concrete with a cement content of more than about 350 kg per cubic meter. Pumping of concrete with a pre-pumping slump of less than 8 cm or 80 mm. Pumping of concrete containing plasticizers or air entraining high range water reducing agents. Pumping of concrete in a construction environment, that is cold weather condition, cold weather concrete or hot weather concrete. Pumping from higher point to a lower point or over a long distance. Pumping or lightweight aggregate concrete, high strength concrete, high fluidity concrete, fiber reinforced concrete, anti-washout underwater concrete, or shotcrete for tunnel construction mentioned in construction special concretes of this specification. If difficulty in pumping of concrete is expected, it is desirable that testing pumping be conducted under realistic piping conditions. If difficulty in pumping of concrete is expected, it is desirable that test pumping be conducted under realistic piping conditions in advance to check on how concrete pump operation, pumping loads, condition of discharged concrete if test pumping under realistic conditions is not possible because of constraints associated, for example, with cost, time, or site conditions. Pump ability may be evaluated on basis of available pumping data obtained under similar conditions or by conducting test pumping under short piping conditions. Simple methods for evaluating pumpability of fresh concrete. Now, prior to pumping of concrete, measures to prevent interruption due to clogging, such as pumping mortar in advance for purpose of lubricating inside surfaces of concrete pumps and pipes. Although quantity of mortar pumped in advance is small, mortar as a general rule must not be pumped into formwork. Prior to pumping of concrete, measures to prevent interruption due to clogging, such as pumping mortar in advance for purpose of lubricating inside surfaces of concrete pumps and pipes. Although quantity of mortar pumped in advance is small, mortar as a general rule must not be pumped into formwork. Concrete living inside of pipe during interruption of pumping may cause concrete living inside pipe during an interruption of pumping may cause blocking due to decrease of pumpability, loss of segregation, and loss of workability. Also, quality of concrete may be adversely affected. Therefore, concrete sent to hopper of concrete pump should be pumped continuously and placed and compacted rapidly. In cases when an interruption cannot be avoided because of segregation and loss of workability, also quality of concrete may be adversely affected. Therefore, concrete conveyed to hopper of concrete pump should be pumped continuously and placed and compacted rapidly. In cases when an interruption is not avoidable because of movement of pipes, shift of workers, rainfall, or whatever other unexpected situation, a resuming time should be informed to persons concerned. In case of interruption over a long period, interval operations shall be done to prevent blocking. If possibility of occurring blocking is high due to interruption of pumping for a long time all of continuous pipes shall be discharged. Gives now we'll in 5 minutes I'll be back. Okay, in 5 minutes I'll be back. We'll discuss this topic of bucket. Very seriously, it's an important issue, bucket, and we'll see how to do it. Let's get in. So I was telling about bugs, about buckets. Buckets, you can say, buckets. Buckets shall be fabricated. Buckets shall be fabricated so that segregation is minimized. Buckets shall be fabricated so that segregation is minimized when concrete is poured in and discharged. Concrete can be easily discharged, and when closed, concrete and mortar do not leak. Method of receiving concrete discharge from a mixture with an appropriately structured bucket and immediately transporting bucket to placing location is convenient because concrete can be transported to placing location by moving it in vertical and horizontal directions easily. For bucket methods of placement, slump correction values under different construction conditions are not specified as for concrete pump method. Bucket transportation, however, is often more time consuming than concrete pumping. Method of moving a bucket with a crane is one of transportation methods that are effective in reducing segregation of concrete. If concrete is left in a bucket which does not have an agitating function for a long time, possibility of segregation and occurrence of changes in workability increases when using bucket method of transportation. Therefore, it's necessary to draw up a plan and perform quality control in view of rate of placement in bucket method and changes in quality of concrete. A bucket used in this method should have an outlet at center of bottom because an outlet located off center tends to cause segregation when concrete is charged. Chutes as general rule, a vertical chute should be used if chute method is used. When an inclined chute has to be used, a general rule, slope of chute shall be steep enough to prevent segregation of concrete and should not be gentler than 1 vertical to 2 horizontal. Concrete transported in an inclined chute is prone to segregation. Tendency to use large slump concrete with aim of facilitating concrete flow may aggravate segregation. It is required as a standard practice, therefore, that when a chute is used, a vertical one should be used, depending on construction conditions. However, there may be cases where an inclined chute requires to be used. Slope of chute must be enough to prevent segregation of concrete and must not be gentler than 1 vertical to 2 horizontal. If concrete does not flow down chute smoothly, it may be necessary to change inclination of chute or modify concrete mix proportions. It is desirable, therefore, that condition of concrete flow be observed in advance by using planned chute and concrete. Chutes must be structured to minimize segregation of concrete. Vertical chutes include ones that has a funnel tube and one made by using flexible tubes. Vertical chute joints must be sufficiently strong so that they do not come off because of impact of falling concrete. Vertical chute joints must be sufficiently strong so that they do not come out because of impact of falling concrete. Inclined chutes include iron chutes with sheet iron linings, chutes consisting of iron pipes and flexible tubes, and lightweight FRP chutes. When using an inclined chute, it is necessary to provide outlet with a funnel tube and baffle plates to reduce segregation. It's good practice when using a chute to wash it with water, and after it is used, and let water flow down chute before being using it. Care should be taken, however, so as not to let water or mortar that has flown down chute flow into concrete or formwork. Lower end of funnel tube needs be kept as close to concrete placement surface as possible, because pouring too much concrete at one location would necessitate moving concrete laterally and cause segregation. It is necessary to carefully consider details such as spacing of concrete inlets and order of pouring. If concrete transported in an inclined chute is found to have segregated, it is necessary to receive concrete at outlet and remix concrete before using it. Other transportation equipment. If a pneumatic concrete placer is used, careful studies shall be conducted to decide on which concrete placer to use and method of use, because transportation distance varies depending on model and type of concrete placer. If a belt conveyor is used, appropriate measures shall be taken for protection from sunlight and weather, and in order to prevent segregation of concrete baffle plates. And a funnel tube shall be provided at discharge end of conveyor. When wheelbarrows, tram cars, etc. is used, transportation distance shall not be longer than 50 to 100 meters. If a flat hallway can be provided, and if segregation control be prevented, like concrete pump, pneumatic concrete placer which pumps concrete in conveyance pipe by compressed air is useful, and in delivering concrete to a constructed space such as a tunnel, distance over which concrete can be transported with a pneumatic concrete placer varies with air pressure, air consumption, model type, and other details of pneumatic concrete placer to be used, therefore need be selected after careful study. Number of bends in conveyance pipe should be minimized. Only horizontal or upward sloping piping must be used. Number of bends in conveyance piping should be minimized. Only horizontal or upward sloping piping must be used, and downward sloping piping must not be used. In a downward sloping pipe, concrete moves under its own weight, and state of flow on which pipe is fitted with concrete is destroyed, so that pumping becomes difficult and blowout of compressed air may result. If segregation of concrete occurs when concrete is discharged from pipe, it's good practice to take such measures as mitigating impact at time of discharge and letting discharged concrete hit a stormy mat, handcloth, or other similar material suspended in front of outlet of conveyance pipes. Using highly viscous concrete, that is concrete with a high sand percentage and a relatively high mortar content, may be effective in reducing segregation. A belt conveyor is convenient for continuous conveyance of concrete. In arrangement of conveyors, not only difference on each conveyor level should be as small as possible, but also conveyors should keep their slope within a certain level, which segregation does not occur in concrete. Longer conveyance distance, longer concrete is exposed to air, causing drying or changing of slump. Therefore, steps must be taken to top belt conveyor with a cover. A device shall be installed at end of conveyor to prevent the position of water on return belt. Provision of baffle plates and a funnel tube is effective to prevent segregation of concrete. If concrete is deposited in a set position by belt conveyor, it must be shifted laterally within forms, resulting in a larger segregation. Therefore, end of belt conveyor shall be able to be moved. Now, what is placement? Preparation. Placement is very important part of concrete. That is final part, placement and finishing, and which we must take care of for us. What is placement now? What is where to do preparation prior to placement of concrete? It shall be ascertained that reinforcing steel formwork and others have been placed in accordance with construction plan. It's a very important point. Prior to placement of concrete, it shall be ascertained that reinforcing steel formwork and others have been placed in accordance with construction plan. Just before placement of concrete is started, insides of transportation equipment. Just before placement of concrete is started, insides of transportation equipment, placing equipment formwork shall be cleaned, and institution of wood fragments or other foreign matter shall be prevented. Whatever material that may absorb water in contact with concrete shall be wetted in advance. Water remained in formwork shall be removed prior to placing concrete. Appropriate measures shall be taken so that water flows into formwork to wash newly placed concrete. And besides, checks to be made prior to placement of concrete. It is necessary to ascertain that neither reinforcing steel nor formwork is likely to be moved by concrete placement work. If transportation equipment is dry, concrete may stick to equipment so that transportation becomes difficult to carry out. If moisture in newly placed concrete is absorbed by formwork, it's often not possible to obtain a good surface finish after formwork is removed. It's therefore necessary to moisten potentially water absorbing regions in advance. Care must be taken, however, not to be excessive in wetting, so pools of water form. If concrete is poured into formwork, if there is a pool of water due to rain, groundwork can flow, curing water, bleeding water from previously placed concrete. Quality or integrity of concrete may be lost. Such water therefore needs to be removed before placement of concrete. If rainwater or groundwater enters formwork, concrete surface may be washed. It is therefore necessary to take rainproofing or waterproofing measures in advance. Placement. Concrete shall be placed carefully so that neither reinforcing bars nor formwork move out of position. Placed concrete shall not be moved laterally in formwork. If severe segregation is identified during placement of concrete, placement shall be stopped, and method of reducing segregation shall be determined and be implemented. Except as planned construction joints, placement of concrete shall be carried out continuously until placement is completed. As a general rule, concrete should be placed so that the surface of newly placed concrete becomes nearly horizontal. Standard lift height for concrete placement shall exceed 0.4 to 0.5 meter. In view of performance of internal vibrators used, if concrete is placed in 2 or more layers, placement shall be carried out so that the overlying layer becomes integral with an underlying layer. Area of each concreting zone, concrete supply capacity, allowable placement interval, etc. shall be determined. So then the coal joints do not result. Term allowable placement interval is time after completion of placement and compaction of underlying layer of concrete until overlying layer of concrete is placed. After a period of standing time, standard allowable placement intervals are shown when a new layer of concrete is placed on a previous layer. Vibrator shall be inserted into underlying layer too far. Now it's 2 hours into 25 hours in case of 25 degrees and less than 25 degrees 2.5 hours. When placing concrete into high formwork, inlet shall be positioned in a formwork or discharge location of vertical chute or pipe shall be lowered close to surface. In such cases, distance of surface of placing from outlet to outlet of chute pipe, bucket, hopper, or other devices should in principle not exceed 1.5 meter. In cases when breeding water appears at surface during placement of concrete, water shall be removed using appropriate methods before placing more concrete. The standard of placement under normal conditions about 1 to 1.5 meter per 30 minutes is desirable, however, that adjustment should be made according to size of cross section. Concrete mix proportions compaction methods. If concrete is a slab or beam is continuous with concrete of a wall or column, it's a standard requirement that placement of concrete slab or beam should be started after settlement of concrete walls or columns has largely ended in order to prevent settlement cracks. In cases where concrete is to be placed directly on the ground, a layer of leveling concrete should be placed beforehand. As concrete placing may disturb reinforcement and forms arrangement, it shall be placed carefully, and it's also desirable that reinforcement workers stand by during placing in preparations or reinforcement disturbance by whatever chance. If concrete is deposited at point far away from intended casting place, it needs to be moved again to planned points. A segregation is likely to occur after each handling. It's important to deposit concrete at placement point to avoid segregation. If several cases of segregation is observed during placement, it's difficult to obtain homogeneous concrete by remixing. Therefore, placing of concrete into form must be discontinued and cause of segregation studied and corrected for subsequent concrete placement. Since construction joints tend to become structural weak points, it is necessary to draw up a plan for continuous placement of concrete and control vehicle operation and placement work so that construction joints are not made except at planned locations. To obtain uniform concrete, it is necessary that concrete be placed as a result in a nearly flat surface. To obtain uniform concrete, it is necessary that concrete be placed as to result in a nearly flat surface within forms and be uniformly compacted by vibration. In case when a lot of concrete is placed in large area, it is recommended to limit concrete placing rate at one point according to capacity of compaction by preparing placing points as many as possible so that the surface of concrete in whole area for placing should keep its flat level. If number of placing points being few, placing rate in each point tends to increase and works may change to be rough. Consequently, possibility not in place, dense concrete becomes high. Therefore, it's important that balance between number of placing points and placing speed is controlled properly. If height of layer is about 0.4 to 0.5 meter or less, which is smaller than length of vibrator part of internal vibrating part of nozzle of internal vibrator, lateral movement of concrete can be reduced. That's why that range is specified as a standard range in the specification. If a layer exceeding that range is placed, it must be ascertained, for example, by conducting a test using a realistic structural model that no adverse effect should have an appropriate construction method must be determined. This clause is given to ensure a consolidated condition between layers when concrete is placed in separate layers. Cold joints may develop if upper layer is placed when concrete of lower layer has begun to harden. For preventing cold joint, it's important that time span until placing new concrete on consolidated fresh concrete be specified and controlled in consideration of effects of type and quality or performance of concrete. Elapsed time between start of mixing concrete to finishing of placing, concrete temperature, compaction method, and so on, especially due to rapid setting, possibilities of occurrence of cold joints in hot weather condition. Hot weather concrete is highest than that of abnormal condition concrete. So normal condition concrete, in case when a lot of concrete is placed in large area, same attention should be paid for taking long time until placing concrete on previous compacted concrete. Average time elapsed for placing concrete on previously compacted concrete is different depending on type of cement, type and doses of chemical admixture, concrete temperature, temperature in the atmosphere, and etc. for normal concrete. This will value given a standard for time elapsed for placing concrete on previous compact one. If the cold joint is highly susceptible to occur, some of countermeasures shall be taken, such as use of retarding type of area and draining and water reducing admixture, reduction of height of one lift, and so on. As matter to establish a available time elapsed for placing concrete on previously compacted concrete before construction and to judge possibility of continuation of placing under problem in construction. There are Proctor penetration resistance test and method inserting reinforcement bar or steel bar for slump test to concrete at construction site. And these methods are carried out. Concrete library could, when the concrete is deposited from high position or discharged from above a build high wall and so forth. Segregation is often caused due to striking of concrete forms and reinforcing bars. It's also possible that concrete deposited on forms and bars subsequently harden, causing interference to subsequent jobs or becoming a defect in structure. In such cases, it's necessary to provide an opening in form of the lowest discharging outlet to a vertical chute or to move pump pipe closer to surface of placement. Therefore, to prevent material segregation being caused by dropping concrete from overhead, falling distance from discharge outlet to placement surface must be defined. If water left on surface of newly placed concrete is not removed, it may wash surface in contact with formwork and cause sand break, streaking, and formation of a weak layer nearly concrete surface. It is therefore necessary to remove water by appropriate means such as sponges, lens, and small submersible pumps. When concrete is placed continuously below the high wall column, it is possible that large pressure will be applied to form or adverse effects due to bleeding arise if concrete is placed too quickly, making upper concrete weak or drastically reducing bonding strength of horizontal reinforcing bars. To avoid this defect, placing speed must be adjusted. It's desirable that speed of be changed in accordance with size of cross section, concrete mix proportions, method of compaction, and so on. But ordinarily, speed of 2 to 3 meters per hour is desirable. In case of certain types of concrete casting slope and shape of cantilevered member and concrete cast as a wall or column continuous with a slab or beam, degree of settlement of concrete differs at different parts of concrete with different cross sections. Consequently, if concrete is placed at a time, cracking tends to occur in boundary zones between different cross sections. This specification requires, therefore, the placement of concrete be interrupted at a location where cross section changes and after settlement of concrete has largely ended. Placement of an overlying layer of concrete, such as concrete will be cast in shape of a cantilever be started. Time needed required for settlement of concrete varies with materials used, temperature, and not be indicated specifically, but is usually 1 to 2 hours. And then compaction outcome. Compaction. In principle, internal vibrators should be used for compacting concrete. Foam vibrators may be used for such structures as thin walls where use of internal vibrators is difficult. Scaffold installation and concreting methods used should be determined so that compaction height does not exceed planned value. Concrete adjustment to sheeting board shall be properly compacted around sheeting board to ensure that final concrete surface is as flat as possible. During compaction, using vibration, internal vibrator shall be inserted about 10 cm into lower layer of concrete. Spacing of internal vibrator and vibration time at each location shall be determined so that concrete can be adequately compacted. Internal vibrators shall be withdrawn gradually so that holes are not left in concrete. Time of revibration should be as late as possible to extend that compaction of concrete is possible and there exists no adverse effect such as cracking on concrete. Civil engineering structures are built with relatively thick members, often made of stiff concrete. As a general rule, therefore, this specification requires use of internal vibrators for compaction because there are many types of vibrators and performance varies among different types. It's necessary to vibrate suitably for construction work to be carried out. And we can say when using external vibrators, it's important among other things to select vibrators of an appropriate type. Firmly secure vibrators to form work and select appropriate installation locations and vibrator moving ahead. In order to achieve required quality and filling ability of concrete, it's necessary to pour concrete from an appropriate height and determine a compaction height from which filling process can be visually observed. Construction standards specification requires the appropriate slump be determined in view of compaction height. It's important to determine scaffolding installation and concreting methods so the compaction height does not exceed planned value. Details such as concrete mix proportions and workability are determined according to dimensions of structural members and reinforcement patterns. In regions that are difficult to fill with concrete, such as densely reinforced regions, therefore it's necessary to carefully compact concrete before workability of concrete decreases. Exposed surface of concrete must be flat. This is important not only for appearance but also for durability and for the tightness of the structure. It's therefore necessary to make sure that sheeting surfaces are flat and mortar does not leak through sheeting joints and carefully placed in compact concrete. Aim of this provision is to make sure that naively placed layer of concrete is integrated with underlying layer. It is necessary to determine internal vibrator spacing and vibration time at each location so that naively placed concrete is vibrated uniformly and to inform construction workers of them in advance. Important consideration in using vibrators including following. Internal vibrators should be inserted as vertically as possible at uniform spacing. The spacing should not be greater than diameter of range in which vibrator is effective, which is usually 50 cm or less, for concrete with average level of fluidity and viscosity. Range in which vibration is effective, however, varies depending on various factors such as diameter of internal vibrators, compaction capacity at different frequencies, fluidity, slump, or viscosity of concrete, dimensions of structural members, and reinforcement pattern. Decisions must be made, therefore, paying attention to filling ability and segregation of concrete. we'll take up, I think, maybe next time. It is, we can say, internal vibration must not be, let's say, there are also other indicators. For example, volume of concrete ceases to decrease, surface becomes glossy, and entire concrete decreases, looks like a uniformly blended mixture. As a rule of thumb, 55 to 50 seconds vibration time is 5 to 15 seconds. So appearance of a cement plastic line along concrete sheeting interfaces an indicator and indicate compaction. There are also other indicators. For example, volume of concrete ceases to decrease, the surface becomes glossy, and entire concrete easily looks like a uniform blended mixture. As a rule of thumb, vibration time is 5 to 15 seconds. Pulling out vibration slowly is very important in order to make sure that holes are not left in the concrete. Intervibrators must not be used for lateral movement, which may cause segregation. Type, size, and number of vibrators needed required to be suitable for compaction of entire volume of concrete to be compacted at a time. To this end, it is necessary to select type, size, and number of vibrators according to thickness and area of structural members, cross sections, maximum volume placed per hour. Maximum size of course aggregate makes proportions. Slump of concrete, although volume of concrete that can be compacted with a single internal vibrator varies depending on site conditions. It's about 5 to 8 cubic meters per hour for concrete to be used for an ordinary structure. Revibration refers to second application of vibrations at a certain time after first compaction of concrete, and to do this, time has to be adequately determined. Revibration given at a proper time plasticizes concrete again, reduce air water cavities in concrete. It's also effective enhancing concrete strength and bonding strength to reinforcement and preventing development of settlement cracks. Benefits of revibration are best attained when it is done as late as possible while concrete still holds plasticity. However, problems such as development of cracks within concrete will arise if revibration is done too late. Moreover, it shall be confirmed that vibration transportation to reinforcing bars does not injure concrete has already been in setting conditions and finishing. I think this is now here. Today we have done this, and I think we have gone through concrete, and there's some refreshers. I will take this next time also, and I think we have done good here. And this is my email ID, certificate, quality, coordination, and concrete. And I think we'll come back to this next time. And this will all be today. Thank you very much.